2 of ellipses. So there are some real-world applications of using ellipses. Obvious one is planetary orbits. Our Earth orbits around the sun in an elliptical fashion, and it actually has an empty focus. The sun is one of the foci, and there's an empty focus here. Okay? So today, we want to talk about how we find the equation of an ellipse based on having the different parts, just like we did with parabolas. We started by graphing parabolas, given an equation, and finding the focus, directrix, and so forth, and the vertex. We did the same thing yesterday. We started with the equation of an ellipse, got it into standard form, and was able to graph it from there. Now we have parts, and we want to be able to get the equation back. So we want the standard form of an ellipse if the vertices are plus or minus 6, 0, and the foci are plus or minus 2, 0. So we start by graphing those two vertices. Negative 6, 0, 6, 0 are the vertices, and the foci are at positive or negative 2, 0. So there are my foci. We don't have a lot of information about it, but first of all, is it a horizontal or a vertical ellipse? Horizontal, because the vertices in our book, they only talk about those major vertices, and it's obviously horizontally spread out. So we know it's a horizontal ellipse, x minus h squared over a squared, because our major axis always goes with the a's, plus y minus k squared over b squared, that's our minor axis, equals 1. Do we know the center of this ellipse? What do you think the center might be? 0, 0. So that makes things easier. H and k are 0 and 0. So we'll have an x squared over some a squared plus a y squared over some b squared equals 1. Do we know how big a is? It's 6, because the distance between our center and our vertex is 6, and that's on our major axis. That's our vertex, or that's our a. So a is 6, right? A squared is 36. So we've got a 36 under our x squared. So now we've got to find b. So we haven't used the foci yet. What did this distance between the center and the foci correspond to? The distance between the center and the foci? I think it was right here. We've got to find C. We actually know C, don't we? And we've got to find out what B is. Okay, so we know C. Yep, only it's not Pythagorean theorem because it's C squared equals A squared minus B squared. C is 2. Okay. Yeah. Okay, so yes, C squared equals A squared minus B squared. So 36 minus B squared. When I take away 36 from both sides, negative 32 is a negative B squared. Yep. And we don't have to simplify that if you don't want to. Good. And we have our equation of our ellipse in standard form. Mm-hmm. Mm-hmm. Yep. So to find A, we knew that our major axis has a length of 12 total. The distance between the center and the vertex is our A. Okay. So in this case, B squared is 32. B is the square root of. Good question. If we wanted to complete this and finish graphing this, the square root of 32 is a little bit less than the square root of 36, so a little bit less than 6. So we would go up 6 or a little bit less than 6. Yep, and that's our minor one. And so we would have something that looks fairly close to a circle because there's not much difference between the two. And that's a horrible circle. But I challenge you to draw them better. Okay? All right, next example. Yep, I'm sorry. All right, next example. All right, now we want the standard form of an ellipse if the foci are at 0, 0, and 4, 0, and the major axis has a length of 8. So we'll start by graphing the foci at 0, 0, and 4, 0. The major axis has a length of 8. So first of all, if the foci are at 0, 0, and 4, 0, where's the center? 2, 0. So we know, and is this a horizontal or vertical? When they say the foci are at 0, 0, and 4, 0, then those two have to be evenly spaced from, okay? In fact, those are going to be C away from the center. Yep, so if it's a length of 8 from the center, we're going to be a total of 4 out and a total of 4 back. That gives me a total length of 8, right? That's the total, right? Not from the center, okay? All right, so we know this is a horizontal ellipse, right? That means that our general form would be x minus h squared over, because it's horizontal, my a squared is underneath the x, y minus k squared over b squared, and 1. Let me rewrite that. Okay? Always going to be plus for ellipses. Monday we'll learn about a minus sign for, I'm sorry. Yep, it was always plus before. Yep. Monday we'll talk about hyperbolas and why it's a minus between. Okay? All right, so HK, H is 2. K is 0. If you want to put the 0 in there, feel free. And we know our total distance between, we know our total A now, don't we? How long is A? A is 4, because between here and here is a distance of 4. So 4 squared is 16. We know that this is C, right? C is 2. Between the the center and the foci is a distance of 2 each. So C is 2. C squared is a squared minus b squared. So if c is 2, when we take away our 16 from both sides, we'll get negative 12. So if a negative 12 equals b squared, then b squared's got to be plain old 12. Thank you. Sorry, lost my sign. And we have our equation. Okay. One more example. This is always b squared down here, so you don't even have to take the square root of it. Okay. Save yourself some pencil lead there. All right, we're good? All right, next one. Find the standard form of an ellipse if the center is at 3, 2, and A is equal to negative or to 3C, and we have foci at 1, 2, and 5, 2. So start by graphing what you know. Three, 2, foci 1, 2, and 5, 2. Again, I'm sorry, got another horizontal one, don't we? So it's going to be in the form of x minus h squared over a squared. If it had been vertical, my major axis would be vertical, so my a squared would be under the y. Y minus k squared over b squared. Okay. So center's at 3, 2. That means x minus 3 squared, right? And y minus 2 squared. How are we going to utilize that a equals 3c? So remember, the distance between the center and the foci is always our c, isn't it? Okay, so this is 2. So 2 times 3 is 6. So a squared is 36. Okay, now we have to find b. So c is 2, a is 6, right? C squared, a squared minus b squared. Taking away 36 from both sides. So what's b squared? 32. And I did not make this big enough to graph it. I don't have my points in the right spots. Okay. Need to fix my slide for next year. All right. I think I have one more example. I don't remember. Yep. Yep, you bet. Mhm, mhm. Right. So you factored your 16 out, so you've added 16, you factored your 25 out, so we're adding 25. And it may not come out nicely. You may have a 1 here, and you may have a 16, 20, or 25 sixteenths here, and that's possible. Okay? I'll show you. Okay, so last example. I believe it's the last one. Yes. All right, here we go. Last example. Standard form of an ellipse. We have vertices now at 0 and plus or minus 8. And again, I don't have the right graph for this. But our vertices are at 0 plus or minus 8. Okay? That means our center has to be 0, 0, doesn't it? Okay? Because we're evenly spaced, we're 0 over and 8 up, 8 down. The middle of 8 and 8 is 0. Okay? This time this is a vertical one. So we will have an x squared plus a y squared because of the 0, 0. And it's vertical, so I will have a total of 64 for my a squared this time. And the 64 goes under the y squared. Because if my vertices are at 8 and 8, that means my distance between here and here, my a is 8. And we square it. Okay? We know our eccentricity is 1/2. Remind me, what does E stand for? So that's C over A. My A is, this time my form is in x squared over b squared plus y squared over a squared equals 1, right? Because my major axis is vertical this time. And that means that my C over A is going to be C over 8. So if 1/2 is C over 8, and we cross multiply, what will C be? Because 8 equals 2C, so C is 4. Okay? If C is 4, that means that my focus will be 4 units away, my foci. And now that we have C, how do we find B? With that formula. The Pythagorean-like theorem, C squared equals A squared minus B squared. So 16 is 64 minus B squared. When I take the 64 to the other side, I get a negative 48. So B squared is a positive 48. So we can throw eccentricity at you, we can throw foci, we can give you lengths of major or minor axes and expect you to come up with it. Yes. We need it in the B squared format, so you're just saving pencil lead. You can certainly do it, but you have to square it again anyway. Okay? All right, assignment today. You can add it to yesterday's assignment. I'll go over any questions you have over yesterday's, but we're saving paper mode because it's the end of the year and paper's not cheap right now.